This is definitely an algebra question. We have a bunch of x's and the choices and the question. But what I would do and notice immediately is that this is probably a good opportunity to arithmetize. It's basically a version of plugging points into equations, but obviously we don't have any points to plug in. We're just given kind of the equations. But arithmetize lets us make up a point and just see how it goes. So what I would do here is make up an easy number for x and kind of just let it work its way through this question. So if I did that, I would have, let's say, x equal to 0. So my original expression then, I'm going to substitute 0 in for all these x's. So it's going to be 4 over 4 times 0 minus 5 minus 1 times 0 plus 1. And I'm writing this out to show you, but honestly I could have done a lot of this math in my head because 0 is such a powerful number. It makes things disappear. So very quickly I would have seen that the first term is going to be 4 over negative 5, and then that's minus 1 over 1. So I still need to kind of condense this. I do have the calculator, right? This is negative 4 fifths minus 1. You can use that. You can also hopefully remember that negative 4 fifths and negative minus, 1 over 1 is 5 fifths, right? So that would be negative 9 fifths. So that's my magic number. Now, obviously that is not an answer because we did something to kind of change the nature of this question. We put x as 0, and that made all the variables disappear. So if we do that in the top, we have to do that in all the answer choices as well, because if x is 0, all the x's are 0, including in the answer choices. And what we're hoping for is that one of these answers gives us the same number, that negative 9 fifths. It's basically like a point that we're testing out in both equations, and we hope that since they're supposed to be equivalent, they share the same point. So let's see what happens. Negative 9 fifths is our goal. I'm going to come down here for choice A. So that's going to be 1 over 0 plus 1, and then 4 times 0 minus 5. I'm going to take some shortcuts in a second. 1 over 1 times negative 5 is negative 1 fifth, so not negative 9 fifths, so that choice is wrong. Let's continue. This would be 3 over 3 times 0 is 0, so negative 6, so that's negative 1 half, not negative 9 fifths. C would be negative 1, I'm going to move that negative so I don't lose it, over 1 times negative 5. So this is positive 1 fifth. Again, wrong. So hopefully it's D. Let's see if I can get it in here. And 9 over 0 plus 1 is 1. And then negative 5. So there it is. Negative 9 over 5 is what I wanted. And that is the answer. So like I said, I showed you a little bit more work on my page than I probably would have done myself. I would have taken a couple of little shortcuts because I'm very confident with the number 0, but I would have shown a lot of this work on my page, on my scrap paper. The other thing too is if sometimes we pick a number that doesn't work out perfectly, if we get multiple answers that do work, we can always pick a different number. Now, I also could have picked a different number from the start, something like 1 or 2, or honestly, I could have picked 200 if I wanted to. But why would I? This is the benefit of arithmetize, is we're making up a number that makes our life easier. So there's no rules here. There was nothing in the question that told me not to pick any certain number, and 0 didn't cause any problems, so I just ran with it, right? Pick an easy number to work with. And it's just a way of trusting the process a little bit and making your life easy. Now, if you wanted to do the algebra here, haven't done a good amount of space saving. Let's go over here. So 4 times 4x minus, or over 4x minus 5 over minus 1 over x plus 1. Basically, if you wanted to think algebraically here, you would need to remember how fractions get combined. In order to do it, we need to have common denominators, which means we're going to need to multiply by the missing piece. So this is going to get multiplied by x plus 1 on both the top and the bottom, and this is going to get multiplied by 4x minus 5 on both the top and the bottom. So the bottom is nice and easy. That's just going to be x plus 1 times 4x minus 5, because that's what both are. And I wouldn't FOIL that out, because if you look at the answer choices, they don't FOIL it out. So why make your life harder? Now on the top, we do need to distribute, and this is where the errors happen. So the first part is 4x plus 4. But when we distribute the second part, we have to remember this negative is part of this. So this negative goes in with the 1, and so this would be minus 4x plus 5. And now the 4x's will cancel each other out, and the 4 and the 5 is what gives us the 9. So 9 over x plus 1 times 4x minus 5, and that is exactly what I got in choice D. So is that faster? Maybe. But I do worry that if we make a mistake, like if we forget to distribute, we might lose kind of something that's important to the question and get it wrong. In this case, I don't really know what answer choice you would get if you did this wrong. My guess is you would end up with a 9 somehow because, well, I guess actually no, you'd end up with a -1, right? Because you would have had positive 4 minus 5. So if you forgot to distribute, you'd have a -1, and notice that's kind of what's going on in choice C. So if you got this wrong and you got choice C, maybe tell me, is that what happened? Is that why you got it wrong? You forgot to distribute? I don't know. I think this is just a good example, though, where part of the strategy is also knowing that you can arithmetize right away, right? We don't need to know what x is, so let's make it whatever we can. That's going to make it easy to see how this thing works without having to do algebra. Algebra is where mistakes happen. Arithmetic is a little easier to handle.